Hello guys, my name is Mr. Manuel. I want to take you through logarithms, the form to logarithms. I am going to point out the common mistakes that students do when doing logarithms. But I want to give you a brief introduction of the topic. I want to start by defining for you some terminologies, and I will want us to start with the word characteristic. Let's start with the word characteristic. What is a characteristic? Characteristic is the number which comes before the decimal point in a logarithm. Characteristic is the number which comes before the decimal point in a logarithm. For instance, if you find the log of a number and obtain 3.5064, the figure 3, which comes before the decimal point, is what we refer to as the characteristic. Another example, should you find the log of a number and obtain bar 1.8754, the bar 1 is again what we refer to as the characteristic, the numbers which come before the decimal point in a logarithm. I want to take note that the characteristic is usually the power of 10 after a number is expressed in standard form. It is usually the power of 10 after a number is expressed in standard form. For example, let's say you want to find the log of 18.64. Let's say, for instance, you want to find the log of 18.64. The standard procedure of finding logarithms is you come up with a table, subdivide the table into 3 columns, have your number, the standard form of the number, and finally the log of the number. The number in this case becomes 18.64. What is 18.64 expressed in standard form? This should be 1.864 times 10 to the power of 1. This power of 10, which is 1, is what we refer to as the characteristic. It is the number which will come before the decimal point when finding the log of a number. I hope that is well understood. When finding the log of this number, I'm repeating one more time, you will take the number, then express the number in standard form. The power of the 10, which in this case is 1, would become the characteristic when finding the log of the number. Which brings us to the second terminology used in linear programming, and that is mantissa. What is the mantissa? The mantissa are the numbers which come after the decimal point in a logarithm. These are the numbers which come after the decimal point in a logarithm. For instance, let's work with this example we were given earlier on. What would be the mantissa in this number? The mantissa would be these 4 figures coming after the decimal, that is 5064 or 8754. That is what we refer to as a mantissa, the numbers which come after the decimal point in a logarithm. And that takes us to the most critical part of logarithms, that is the division of logs. And this is the area where most of the students miss it. Take note, and I want to say this on a serious note, when dividing logs, be very cautious when the characteristic carries a negative, or what we would call a bar. For positive numbers, a student is always allowed to engage a calculator directly. though this would cost you a lot if you do the same for a log where the characteristic is carrying a negative. I want to take you through the division of logarithms, and I want to follow this with me. I want us to take some examples here. Division of logs. I want to take you through some 3 examples. The first one, okay, let's divide the following logs. Divide the following logs as indicated. Divide the following logs as indicated. You are given 2.4083. You are required to divide by 3. So we are taking this one here as the log of a number already, which I intend to divide by 3. But take note, this number is a positive. The student is allowed to engage the calculator directly, especially when the characteristic is a positive. So for this one, there's no much big deal with it. A student is only required to feed the numbers into the calculator directly, then give whichever answer the calculator gives. So let me take you through that one. That will be 2.4083. We want to divide by 3. What do we get? That should be 0.8028. 0.8028. So whenever the characteristic is a positive, I repeat, there's no much big deal in the division. A student is required to engage the calculator directly. When the characteristic happens to carry a negative, for instance, we have got over 4.3067. We want to divide by 3. We want to divide the log of a number by 3. Take note of this. This time, the characteristic is carrying a negative. And you are advised to exercise a lot of caution when dividing logs, and especially when the characteristic carries a negative. Follow this with me. We have about 4.3067. We want to divide by 3. When dividing a number carrying a negative or a bar, the first thing you'll be required to do is to check the characteristic against the denominator, the number you intend to divide it with. What is our characteristic? It is 4. What do we intend to divide it with? 3. Is 4 divisible by 3? The answer to that question is a big no. So what do? We move to the next number, which comes after 4. The next number in our normal counting. In our normal counting, the number which comes after 4 should be 5. But then, 5 is also not divisible by 3. So we move again to the next number, which will be 6. Is 6 divisible by 3? Yes. If 6 is divisible by 3, then you will indicate the 6 first. Then ask yourself, how many times have I moved from the old characteristic to this new characteristic? We have moved twice. From -4 up to -6, we have moved twice. So that 2 should be indicated after writing an addition sign. Then you follow it with the mantissa. Put the whole thing all over 3. What is about 6 divided by 3? That will give us the characteristic, which will be by 2. Then what is 2.3067 divided by 3? Being a positive number, the student is allowed to engage a calculator. Let's see what we'll get if 2.3067 is divided by 3. That will be 2.3067. We want to divide by 3. What result is it giving us? 0.7689. In this particular case, we are just interested in the mantissa. So we'll just indicate 7689. I hope that has been understood. I want to give another example for purposes of clarity. I'll give another example for purposes of clarity. Let's consider bar 5.4084. We want to divide by the number 4. Bar 5.4084, we intend to divide by the number 5. Follow this one with me closely again. We've got bar 5.4084, we want to divide by 4. How do you divide this log again? We check the characteristic against the number we intend to divide it with. What is the characteristic? It is 5. So the question is this characteristic divisible by 4? The answer to that is a no. So what do? We move to the next number after 5 in our normal counting. In our normal counting, the number which comes after 5 should be 6. So we've got 6, 7, 8, and so forth and so on. In our normal counting, the number which comes after 5 should be 6. But then there's a problem. 6 is not divisible by 4. If 6 is not divisible by 4, you will be required to move to the next number after 6. And that number becomes 7. The question is 7 divisible by 4? Again, no. What do? We move again to the next number coming after the 7. And that number is 8. Is the 8 divisible by 4? Yes. So what do? We write the 8. Then ask yourself a question. How many times did we move from the old characteristic to this new characteristic? We moved thrice. From 5 to 8, we moved thrice. So that 3 will be written after the bar 8, but of course after writing the positive sign, then follow this with the mantissa, which is 4, 0, 8, 4. Then we'll take the negative 8 or the bar 8, then divide by 4. What's bar 8 divided by 4? That should give us bar 2. Then what's 3.4084 divided by 4? Being a positive number, again, the student is required to engage a calculator. Let's find out what that will give us. 3.4084. What would be this number divided by 4? The result would be 8521. We are not interested in the 0, but rather the numbers which are coming after the decimal. That should be 8521, which you call the mantissa. We'll have 8521. I hope you have understood how to divide logs. This is one area where very many students make a mistake. They divide logs which are carrying a negative directly in a calculator, which is one of the biggest mistakes that students do. Let's move on to the next step now. Having known how to divide logs, I want to take you through the multiplication of logs, which is again very critical. Another area where many students again make mistakes. Let's move to the multiplication of logs. We are going to look at, let's look at multiplication of logs. Here, I want us to multiply out the following logs. Multiply out the following. Multiply out the following logs as indicated. Multiply out the following logs as indicated. We've got 1.5077. We want to multiply by 2. We've got negative 1.3094. We want to multiply by 3. Let's change this to 8, please. Let's have by 2.9526. We multiply by 2. Once again, take note, where the characteristic does not carry a negative, once again, the student is allowed to engage a calculator. So for the first one, being a positive, we are going to engage the calculator in the multiplication. So we'll take 1.50 multiplied by 2. The calculator is giving us 3.0154. 3.0154. Then as for the second one, The second one carries a bar. This is where the student is required to exercise a lot of precaution. We have got number 1.8094. We want to divide by 3. We want to multiply by 3, sorry. I want you to take note of this. There are very many styles of doing this, but I want us to embrace the easiest ways of doing this. So what do you do? When you're given this one here and you're required to multiply by 3, just multiply the two numbers without engaging a calculator at any stage. Try as much as possible to keep it manual throughout the process. In this particular case, I'll multiply 3 times 4, which will give us 12. So write 2, then carry 1. What will be 3 times 9? That will give us 27. Add the one that we carried, that will give us 8, we carry 2. What is 3 times 0? That should be 0. Plus the 2 we carried should give us 2. 3 times 8 should give us 24. We'll write 4, then carry 1 to the side where we had the characteristic. Carry 2 to the side where we had the characteristic. Now what is 3 times negative 1? That should give us negative 3. That is when you add the 2 which we carried. Negative 3 plus 2 should give us negative 1. I bet you won't get the same thing if it is fed into the calculator directly. Avoid using calculators in multiplying and dividing logs. But let's confirm if that is true. I want us to multiply this one direct into the calculator and see if the answer we get will be matching the answer I'm presenting you. Let's find out. Let's take negative 1. Negative 1, take note, a bar is more or less the same as a negative. 0.8094. We multiply by 3. What is the calculator giving us? Negative 5.4282. Well, in logs, this cannot work. You realize that the characteristic I'm having is not the same as that the calculator is giving us. Take note, when multiplying logs and dividing logs, try and minimize the use of the calculator. We'll proceed. That now takes us to the third one. As for the third one, we have got but 2.9526. We want to multiply by 2. How do you multiply the two logs? Again, follow me. Like I've cautioned you, minimize the use of a calculator. It will give you answers which don't work for logarithms. So what do we have? What is 2 multiplied by 6? That will be 12. We carry 1. 2 times 2 will be 4, plus the one we carried should give us 5. 2 times 5 will be 10. We'll write 0, then carry 1. 2 times 9 will give us 18, plus the one that we carried, that should be 19. We again carry 1. Then 2 times negative 2 will give us negative 4. Then add the one which we had carried. That should give us negative 3. So when by 2.9526 is multiplied by 2, we get by 3.9052. I bet again that won't be the same answer that you'll get if you want to feed this number direct into the calculator. So my advice to the learner is try to minimize the use of calculators, especially when multiplying and dividing logs involving a negative or what we refer to as a bar. That one understood. I want us now to come to a question, a full question of logarithms, and see how to solve it. Now I want to take you through one which does not involve any power, and that will be, I want us to work with the second one. So we have got this one here. You are told to use logarithms to evaluate. Use logarithms to evaluate. You are given the cube root of 36.15. times 0.02573 all over 1.938. You are required to use logarithms to evaluate that. The standard procedure of solving questions in logarithms will always be the use of a table. So we are going to come up with a table with 3 columns. In the first column, we will have the number. In the second column, we will have the standard form of the number. Then in the last column, we will have the log of the number. We will start with 36.15. How do we find the log of 36.15? The student is required to start by expressing this number in standard form. So what will be this number in standard form? 3.615 times 10 to the power of 1. This one, like we had said earlier on, will become our characteristic. Where do we get the mantissa from? The mantissa, the student is required to read from the mathematical table. I hope that every listener knows how to read the table. I'll do this without necessarily showing you. We have got 3.615. We'll read the log of 3.615 from the 4-figure table. The log of 3.615 should be 5581. 5581. If you're following with me, I hope you have also read the same thing from your 4-figure table. It should be 55. The mantissa should be 5581. Which takes us to the next number. What should be the next number? The next number should be 0.02573. What is this number expressed in standard form? The number will become 2.573 times 10 to power negative 2, because the decimal point moved twice. Like we said earlier on again, this negative 2 would become our characteristic again. So we'll be having but 2 point. As for the mantissa, the student is again required to find the log of this number from the table. So we are going to read the log of 2.573 again from the table. 2.5, we've got 7 here. The column of 3 is reading 5. I want to hope that each one of us know how to read the logs of numbers from tables. If the 5 is added, that should give us 4104. 4104. What do we do? In logarithms, should you come across multiplication, the logs of the 2 numbers is supposed to be added. While for division, the logs of the numbers are subtracted. Because we have got multiplication between these 2 numbers, the log which we had got obtained earlier on and the one we are having right now will be put together through addition. So the 2 logs will be added. What do we have? What is 1 plus 4? That will give us 5. 8 plus 0 will be 8. 5 plus 1 would give us 6. 5 plus 4 would give us 9. Then 1 plus negative 2 should give us negative 1. I hope you are following me. Which takes us now to the next number. And the next number should be 1.938. 1.938. What do we do? Again, the student is required to start by expressing this number in standard form. That will be 1.938. But because our decimal point is moving nowhere, the power of the 10 becomes 0. This 0 would then become our characteristic. We'll then move to our table and read the log of 1.958. The log of 1.958. 1.9 5, 8. What do we have? We'll have 29, 1, 8. The two logs will then be subtracted. So how do we subtract the two logs? Like we had mentioned earlier on, we will subtract the two logs, but I will caution you against using a calculator again, especially where bars are involved. Especially where bars are involved. 1.938. 1.938. 38. Okay, just something to correct here. This is not what we're actually giving. It's supposed to be 0.2856. We'll be adding the number 18. This one should give us 4. Carry 1, 7, 8, 2. The figure should actually be 0.2874, not what we had given earlier on. So these two numbers will then be subtracted. How do we subtract the two numbers? What's 5 minus 4? That should give us 1. 8 minus 7 should give us another 1. Borrow 1 from the 9 to give us 16. That should give us 16 minus 8 would give us 8. What do we have remaining here? 8 minus 2 should give us 6. Then bar 1. So we have got bar 1.6811. Now this number will then be divided by 3. The reason why we are dividing the number by 3 is because of the cube root. So in logarithms, where powers happen to appear, we multiply. And where we have roots, that's where division is involved. Because we have got a cube root, this log will then be divided by 3. Like we mentioned earlier on, when a log carries a negative, or what we call a bar, the division of the log is special. So I want us to go through the division process again. How do you divide the two logs? Like we had mentioned earlier on, this is bar 1. We want to divide by 1 by 3. What's bar 1 divided by 3? 1 is not divisible by 3. So what do? We move to the next number after 1. In our normal counting, the number which comes after 1 should be 2. So we move to 2. Is 2 divisible by 3? The answer again to that one is no. We keep moving. Which number comes after 2? The number which comes after 2 now should be 3. Is 3 divisible by 3? Yes. What do? We'll put down the 3, then ask ourselves, how many times did we move from the old characteristic to this new characteristic? We moved twice. So the 2 will be written, followed by the mantissa, which is 6811. Take note, after writing the 2, remember to follow it with a decimal point before you write the mantissa. Now, bar 3 divided by 3 should give us bar 1. Then 2.6811 divided by 3. Like we mentioned, the number being a positive, you are allowed to engage the calculator. What do we have? 2.6811. We are dividing by 3. That should give us 8937. Our mantissa becomes 8937. The mantissa becomes 8937. Having cleared everything, the last step we'll be taking is to move back with this number. Take note, a journey backwards would mean that this -1 becomes a power of 10. So this will become 10 power -1. The -1 has moved to its rightful place. Then as for the mantissa, we will move to the table, then obtain the anti-logarithm of 0.8937. We'll find the anti-logarithm of 0.8937. Take note of something. When you come to the tables of anti-logarithms, you notice that all the numbers are starting with a decimal point, which is consistent with what you're having here. We are looking for the anti-logarithm of the mantissa, which should be 0.8937. And here we have 0.89. We will move to the column of 3, then to the column of 7. The number is reading 13. That should give us 7.829. Times 10 to the power negative 1 should give us 0.7829. This is what you are required to present as the final answer. I'm taking you through one more example, just in case there could be any part which is not clear to the student. It is a good idea that upon finishing this, if time can allow, test your answer if it gives you the same answer you are presenting. I'm afraid we don't have that much time, but let's trust that this is what you'd get if you were to feed the figure directly into the calculator. That takes us to a second example. That brings us to a second example. I wish to take you through this one here. So this time round, I want to take you through an example where an example involving powers. And I'll take you through this one. We have got the cube root of 83.46 times 0.0054 divided by 1.56 squared. I'm picking this example in particular just to expose you to the questions that would involve powers. What do we do? Like I mentioned earlier on again, all the standard procedure of solving questions of logarithms is the use of a table. Let's come up with our table once again. We will have the number, then the standard form of the number, then finally the log of the number. Let's start. The first number there will be 83.46. Let's start with 83.46. What's 83.46 in standard form? This should be 8.346 times 10 to the power of 1. This power, like we mentioned already, will become our characteristic. So we'll be having 1 point. We'll then move to our table and read the log of 8.346. We've got 8.3. We move across to the column of 4, then the column of 6, the number reading 3. That should be 92.15. That will be the mantissa. Taking us to the next number. The next number should be 0.0054. What is this number in standard form? This should be 5.4 times 10 to the power of negative 3. Take note, the decimal point is moving twice. This negative 3 will then become our characteristic. How do you find the mantissa? We'll again move to our table, then find the log of 5.4. The mantissa is 73.7324. The 2, like we already mentioned, should be added because of the multiplication sign. So what do we have there? 5 plus 4 should give us 9. 1 plus 2 should give us 3. 2 plus 3 should give us 5. 9 plus 7 should give us 6. We'll carry 1. 1 plus 1 will give us 2. 2 added to negative 3 should give us negative 1. And that now brings us to the denominator. What do we have in the denominator? We have 1.56 squared. Avoid squaring the number like some students do. Logs has got special approaches to powers as well as roots. So just take the number 1.56, express it in standard form, obtain the log. The square will be taken care of by multiplying the log by 2. Take note. We'll take the number, then express in standard form. This will be 1.56. times 10. Because the decimal point is moving nowhere, the power becomes 0. Do not worry about the square. Logarithms has got a special way of taking care of the squares, the powers and the roots, I mean. Take note of this. The 0 will then become our characteristic. How do we find the mantissa? We'll again move to our table, then obtain the log of 1.56. This is 1.5. The column of 6 is reading 1931. 1931. What do we do? This log should then be multiplied by 2, and that's because of the square, or because of the power 2. If the power could have been 3, then this log will be multiplied by 3. But in this case, the power is 2. So the log of the number will be multiplied by 2. So what do we have? 2 times 1 will be 2. 2 times 3 will give us 6. 2 times 9 will give us 18. We carry 1. 2 times 1 will give us 2. Plus the 1 we carried should give us a 3. Then 2 times 0 will give us 0. What do we do with this one? Take note, like we already agreed, division in logarithms will translate into subtraction. So the answer which we obtained from the numerator, which was about 1.6539, will then be subtracted from the number we are having here. Because of the limited space, just allow me to take this shortcut, please. We are going to subtract. Take note, the number, we'll be taking this number, that is about 1.6539, the result of the numerator. Then we subtract from the result of the denominator. So take note, it is this number and this number that we are subtracting. So let's subtract the two numbers and see what we get. What's 9 minus 2? That would give us 7. What do we have here? 3. Borrow 1 from the 5 to give us 13. Minus 6. That should give us another 7. What do we have left after borrowing 1? 4. Borrow 1 from 6 to make it 14. What's 14 minus 8? That should give us 6. What do we have left after borrowing 1 from this number? 5. 5 minus 3 should give us 2. Then by 1 minus 0 should give us by 1. I hope you're following me. This number will then be divided by 3. Why are we dividing it by 3? Like we mentioned already earlier on, in logarithms, whenever there is a power, you'll be required to multiply the log by the given power. And where we have a root, you divide by whichever root you're given. Because we have got a cube root, this log will then be divided by 3. Like we already mentioned, the division of logs is a special one. The student is required to exercise again a lot of precautions when dividing logs. So how do you divide this one? Like we've been doing, check the characteristic against the mantis. Against the denominator. What's our characteristic? By 1. What do we want to divide it with? 3. What do you realize? 1 is not divisible by 3. So you are required to move to the next number after 1. In our normal counting, the number which comes after 1 is 2. Is 2 divisible by 3? The answer to that is again a no. We move to the number coming after 2, and that should be 3. Is 3 divisible by 3? Yes. So have your 3, then ask yourself, how many times did we move from the old characteristic to this new characteristic? We moved twice. So write the 2, follow it with the mantissa, but take note, the decimal point must be there to separate them. But 3 divided by 3 should give us 1. Then this number being a positive, will engage our calculator. 2.2677. We are going to divide by 3. That should give us 7,559. What do we do? We are done with everything there. Now in the last step, the student is required to move backwards. We agreed that in the backward journey, this -1 would become a power of 10. This -1 would become a power of 10. Then as for the mantissa, you will obtain the antilog of the mantissa. In this case, the mantissa is 0.7559. 0.7, we are reading tables of antilogarithms. 0.75, what is the column of 5 reading? 5.689. The column of 9 is reading 12. If 12 is added to that number, we are supposed to have 5.701. 5.701. I hope you're getting the same thing. This one, as an ordinary number, should be 0.5701. That becomes the result. I would encourage you to observe neatness when doing logarithms. That is one of the reasons, again, why students fail this question. I hope you have enjoyed this. Thank you very much.